Welcome everyone back for another lesson. In the previous lesson, we finally put together our 3D world. We have a camera we can rotate. And in previous lessons, we've drawn points, lines, and now we're going to move on to triangles. Triangles are the fundamental shape of all our 3D objects that you'll ever draw. Every complex mesh is made up of just a bunch of triangles. So instead of going through the exercise of building a single triangle, we're going to build two, which will form for us a quad. A quad is a very basic shape that has a lot of uses, and we'll discuss some of that later down the line. But for now, let's just focus on the point that a square is made out of two triangles, and we have 4 points. There's several ways we can draw a square. One way is to draw all the vertices in the right order. And if we just draw the vertices alone, we have to duplicate certain positions. Position 0 and position 2 gets repeated twice. So instead of just drawing the vertices with repeats in them, we can use indexes. So this way we can have our 4 points, then have our index actually tell us the order in which we build each triangle. Using an index has a lot of good benefits. One thing is the more complicated the mesh, the less repeat of data we have in our vertices array, which would mean we consume less memory. So that's really one of the reasons why we use index, really just to conserve the amount of memory, because an unsigned int, a single unsigned int is a lot smaller than 3 floats. Another thing we're going to put together is our UV coordinates. It's going to be one of the attributes for our vertices. A UV coordinate is really just an X and Y coordinate used for textures. So this way we know how to interpolate what pixels to get from the texture. We're not doing textures in this lesson, but we will probably do them in the next lesson. But for now, we're going to build the UV values, because we can actually use the UVs for more than just textures. We're going to have two shaders that utilize the UVs to actually do other fun things with it beyond just textures. And one thing you might notice is that UV's coordinate system is different from our WebGL coordinate system, where the center of our canvas is 0, 0. But UV 0, 0, the origin starts at the upper left corner. So just keep that in mind, that the coordinate systems are different based on the 3D positioning that we're doing and the coordinates of textures itself. So all right, let's start doing some coding. The first thing I'm going to do is fix a bug I found when I was debugging. So let's open up our render loop file. And if you see on line 18 and 19, I fixed the if statement because it was not taking in an FPS value that I was using. So that fixes a bug in that. So in the event that you need to debug or your computer's running a little slow because you're rendering the frames too fast, this way, with this bug fix, the FPS value that you set will actually work correctly. So this way you can set it to 30 frames per second and give your computer a chance to render a little slower, but still at a good rate where you can see the animations run just fine. Now we're going to open our gl.js file, and we're going to do a couple of settings. Some of the first settings we're going to do is set up calling. Calling allows us to say not to render the back of a triangle. So that's the first thing we're doing. We're saying don't render the back of the triangle, and we're setting up that the front of the triangle is known by putting the vertices in a counterclockwise manner. It's actually by default counterclockwise, but I'm setting it here just for good measure. It's just to remind us that all triangles have to be drawn counterclockwise. And then we just enable depth test. And depth test allows us to render things based on Z position. So the things further away from the camera gets overridden by things closer to the camera. Without it, things will render on the order that they exist on the render loop. So if the things further away render last, then they go on top of things that are closer. So with depth test turned on, that disables that kind of functionality and lets it be a little bit smarter that how it renders. It renders things closer and ignores everything further away. So we enable depth test, we enable call face, and then we tell it what type of depth function to use. There's probably a few, but this is the one that we want to use, is less than or equal to. And then we have blend func. Blend func allows us to use the alpha of our colors and textures. Without blend func set up and blend func turned on, which we're not turning on by default. We're only going to turn it on by default when we need it. But we're going to set up the function as a certain default that's going to most likely be used by all our other shaders. So we're going to do that later today. We're going to play with alphas. So we're just setting this up for now. Now we're going to move on to our primitives.js file, and we're going to build our quad object. As you can see, building a quad doesn't take a lot. We have our create model, which then calls our create mesh. And all we have is 3 buffers that we're going to set up. We're going to set up our vertice, which builds a quad that is 1 unit big in all directions. And then we set up the UV coordinates for each one, just like what I showed you in the first slide. And then we're going to set up the index, and this creates our triangles. So the first triangle uses the first vertice, the second vertice, and then the 0, 1, and 2. And then the second triangle starts at 2, connects to 3, then connects right back to 0. That creates our 2 triangles. So this way we don't repeat vertices. And then everything else is pretty simple. And we're adding these 2 new things called no culling and do blending. And we're setting by default. Right now, our shader functionality can't use those settings, but we're going to add them later on. And then you can be able to see the difference between culling and blending. Now we're going to start modifying our view HTML page. At the very top, we're going to create a new global variable called gmodel2. And we're just going to do this because I want to show you that we can render 2 quads on the screen. And each quad would be a model with its own independent transformation matrix. But they're going to both be sharing the exact same mesh data. So once we have that global variable set up, we're going to move on to line 39 and start setting up our shader, which should be almost the same as our previous lesson. And then we're going to put in our quad. And we're going to set the position, and we're going to set a different scale for our quad. And then as you see, for line 44, we have model 2, which create a new model, and we're going to our mesh cache and getting our mesh data. So this way, we only make the mesh once, and then we just reuse it over and over again. So then we scroll down, and we go to our unrender function, and we update our GShader line of code. As you can see, that what we're doing is actually reusing the shader to render 2 quads at the same one after another. So this is kind of one way we can render multiple objects on screen. Right now, at this point, we're going to have 3 objects. We have our grid, which runs on its own shader, and then we're going to have 2 quads that's going to run on a shared shader. And then after that, we're going to update our test shader function, object, I should say. And it's very bare bones, very simple. It doesn't really do much compared to what we need. It's very simple compared to our previous lesson. And then we scroll down, and we're going to modify our shaders. And the only things we're going to change is our fragment shader. And our fragment shader, we're going to build a border around our quad. We're going to color it black, and the center is going to be colored white. So that little shorthand if statement is we're basically defining the border based on the x and y coordinates of our UV. This is the reason why we're using texture UV coordinates, because we can use it this way to actually define certain aspects of within the quad. Like for here, we're going to define what the border is. It's anything less than 0.1 or greater than 0.9, and on both directions on x and y, this creates a nice border for us. Now if we go back to our browser and refresh, now you'll see our 2 quads are there, and when we start rotating, it disappears. That's because the back is not rendering. This is what calling does. You get to see the front, but the back does not render. So we need to fix this because sometimes we want to see the back side of our quads. There's a lot of instances that the back and front of the quads need to be rendered. So let's go back to our shaders.js file and scroll to the bottom of our shader object and start fixing its render model function. As you can see, I have we changed highlighted. We're going to add in checking to see if no culling and do blending is available. So if we set true to no culling, we're going to disable that setting. So this way we can see the back of the triangles. And do blending means we're going to turn on our alphas, and because we want to see the alpha, because the way we drew in our shader is that we have a black border and the white part is actually transparent, but without blending being turned on, it just shows up as white. So but turning do blending on, that white should actually disappear. We should actually be able to see through that white area. And looks like I might have fixed line 45 in case there was a bug. I'm not sure, but I did highlight this, noting that this line might need to be changed. Because I think it says index count, because I think it had a different value there, different name. I think it was probably index length, and I guess at some point I changed it to index count. Makes more sense. And then line 50 and 51 is undoing our change, because if we want to set these by default and only change them during the times we're rendering. Since we're duplicating or we're running the shader multiple times, this is probably not the best place to do these settings. We probably should do these in pre-render and maybe make a function call on render end. So this way we can save time in processing. Because if we're going to render a bunch of quads the way that we're doing, it's better off not turning it off and on and off, on and off every time we draw an individual quad. We should actually make this smarter. But for now, this is how we're going to do it, just to make things easier. Now that our shader is set up with our new settings functionality, let's go back to primitives and turn on no culling and do blending. So this way we can see what our new settings actually does. So now back at the browser, when you refresh, there you go. Now it actually functions the way we really want it to function. The white area is completely transparent. We can see the grid right through it. And we get to see the back side of the square. We can see the front and the back, and it's always there. It's exactly how we want to actually render this quad. So let's go back to our HTML page and have some fun with the fragment shader. Now, as you can see in the code I have now, that I comment out the square border. Now, what we're going to do is use the UV coordinates to actually make a circle. And we're going to do this by using its center. And its center is different from WebGL, where at WebGL, the center of our canvas is 0, 0. Our coordinate system is different with UVs, which is the origin starts at the upper left corner of a square. So all we do is define our origin, and we try to calculate the distance from the origin. And then we just draw a circle that goes as far into the quad as possible. So it will go from center all the way to 0.1 distance away from the border. So the circle will actually take up most of the quad. And that's pretty much all this is really doing. And once you go back to the browser and refresh, you see that our black squares that are transparent center is now white. Not white, sorry. It is now a black circle. And that's a nice little neat trick of using the UV system to just draw circles. So this way we don't even need textures to do some certain things. With a little bit of fun and a little bit of mathematics, we can do just rings instead of circles. You just got to define different positions of where to stop. I'm not going to cover that, but something you should try. Just mess around with it. Since I gave you the base code, to play with it. See if you can make a ring instead of just a circle, kind of like how the square that I created was really just a border of a square, and I kind of cut a hole through the center. See if you can cut a hole through the center of a circle, make that transparent as well. That might be a fun little challenge for you guys to do. And now we're coming near the end of the lesson. Now, I showed you that we're rendering two quads. but we're doing it separately using the same shader. Now, that is a way to go about doing it. This gives us control of the transform of each individual quad. But there's a problem. We want to render, let's say, 100 quads or 1,000 quads. At that point, we're doing too much rendering. And the notion is that if we don't need to have that level of control per quad, it's not the best idea to do it this way, because we're wasting a lot of time rendering one object at a time. These are kind of called draw calls. We're doing too many draw calls. We're doing one draw call for each quad. Now, this is going to be a problem if down the line, because let's say you want to draw like tons of grass in your world. You can't do it this way, because this will take too many draw calls. If you need to draw 100 blades of grass, because that's what you usually normally use quads for, you just texture them with glass with transparency, and then now you have tons of grass. That's a problem, because we're doing too much draw calls. So an optimized way of doing it is to actually create a single mesh that actually has 100 or 1,000 quads in it. And then, but the thing is, it's tricky, because you now have to do a lot of the math yourself on the CPU end, instead of just drawing everything at origin and then using a transform to move it around the universe for you. So if we go back to our primitives.js file, we're going to add a new class called multiquad. And what this thing does is creates 10 quads, and you can change it to make 100 quads, 50 quads. It's all in the for loop. And what it does is calculates a default or a random position in our space based on certain ranges, because I don't want to go too far away. I want to keep everything within the vicinity of the grid. So we do a random size, we do a random angle, that it's based a random angle in the y coordinate system. So with this, we're going to just spinning the square around, and that's it. And that's it. And we kind of just do a bunch of math to kind of build our quad at that part of space and at that specific angle. So that's what a lot of the math that we're doing is doing. Between lines 25 and down to 39. So that's all it's doing. It's just creating a bunch of quads randomly, in different sizes, different positions, and different rotations. And then it kind of just builds up our array. It just adds it all into our vertice array. So it becomes a single mesh. And then we just follow the rest of the code. And we create a UV for each vertice, and we create an index. So this way, we're building our index for our vertices. So now that we got our 10 quads in a single mesh, we're going to go into our HTML page and start getting it ready to start rendering. So when we go back, we're going to keep gmodel and build our multi-quad model there. And we're just going to comment the rest of the stuff that we don't need. And then in our render loop, we get rid of model 2, the second rendering, because we don't really need that, because now we're going to just render one big massive mesh with all our quads. And after that, if you go into our browser, you'll see that we have all these now quads in our space. We can sit here and rotate around, and they're all there. They're just a single mesh that we created. And this is really one of the optimized ways of actually getting a lot of things on screen and rendered in one single draw call. This would only kind of work when things are kind of uniformed. Like an example of a blade of grass, we have a single texture. And that's kind of one way to go about it, because if you have a single texture, you can share it. There's other things like texture atlases, which allows you to have a single texture image that's kind of divided up with squares, or it's kind of hard to explain. It's just really a single texture that's composed of many textures inside of it. A good example would be Minecraft. Minecraft has a single texture file, image I should say, and it has all the textures like ice, dirt, grass, all in there. And that's another way to kind of optimize things. So you can have like, you can draw a single mesh of tons of cubes, and then have a single texture with the texture atlas set up. So this way you can apply different textures for different faces on each cube and do it all in a single large massive mesh. So that's that's something hopefully going to do down the line. I haven't done atlases yet, but once we start doing cubes, I want to do an atlas, and I want to do a sky map. That's all stuff that you can do with cubes too. Like I said, quads are very important. Quads, you do a lot of things. With quads, we can have blades of grass. Every single image, every single piece of text you see in 3D space is actually a quad. Each letter is a quad textured with that one specific letter. And you kind of have to build this one mesh. It's like, say, if you want to make a paragraph, you have to lay out the quads in the right positioning and with the right texture. And then again, you do a texture atlas. You have a single texture image that has every single letter in that specific font. So this way you can texture it. Another thing you can do with quads and texture quads specifically is particle systems. Some particle systems require you actually use quads that get moved around a lot. So like I said, that's why I kind of focused a lot on quads and why it's important, because it is a very fundamental shape that you're going to use a lot down the line. Like I said, you got text, certain like blades of grass, particles. There's probably tons of other things like planes. You can make walls, I guess. So yeah, quads are very important. It's like, just learn how quads are and how to use the triangles to build a quad. Once you get that fundamental piece down, any larger mesh is a little easier, because quads are the most simplest mesh you can make. And from there, if you understand how that works, bigger meshes are a lot easier, because they're pretty much just rinse and repeat. Just a lot of quads, a lot of triangles just stitched together. So that's it for this lesson. I hope you got to learn a lot, kind of like foreshadowing a lot of the future, like what quads are for and how you use them. And hopefully you guys had some fun, playing with some of the new shader code, making circles and making squares. We can blend, we can use alpha, playing with culling. You can see the back of your quad, or you don't. So that's about it for now. So I guess I'll see everyone in the next lesson. Don't forget, please subscribe or like this video. Please leave comments. I would love to hear what you guys say. If there's anything I can do to improve these videos, I would love to hear it. This is for me as well as for you. Help me make a better product for you guys and make it easier for you guys to learn how this stuff works. I'm still learning myself, so anything you don't understand or you don't get, feel free to ask me questions, and maybe I'll make a follow-up video answering a lot of your questions. So, all right, so I think this is enough. I've been talking for over 23 minutes, and see everyone at the next lesson.